Here is something they never taught you in school. In the spring of 1942, the most powerful nation on Earth was on the verge of losing the largest war in human history, not because of a military defeat, not because of a failed invasion, but because of a tree. A tropical tree that grew in a narrow belt of jungle 15 degrees north and south of the equator. A tree that bled white when you cut it. The Hevea brasiliensis, the rubber tree. And by February of that year, every single one of those trees that mattered was in the hands of the Japanese Imperial Army. Let me put the numbers on the table so you understand the scale of the disaster. In 1940, the United States consumed more rubber than any other nation on Earth, over 600,000 long tons per year. 97% of it came from plantations in British Malaya and the Dutch East Indies. 97%. That is not a supply chain. That is a single thread holding up the entire American war machine. And on February 15, 1942, when the British garrison at Singapore surrendered to General Yamashita in the most humiliating defeat in the history of the British Empire, that thread was cut. The consequences were not theoretical. They were immediate and physical. A Sherman tank rolled off the assembly line carrying half a ton of rubber. Every inch of military wiring was wrapped in rubber insulation. Every gas mask seal, every waterproof poncho, every tire on every truck in every convoy was made of rubber. A single battleship contained 20,000 rubber parts. 32 pounds of rubber went into the equipment of every individual soldier. Without rubber, planes could not land, ships could not seal their hatches, jeeps could not drive, guns could not recoil. The United States military was a rubber machine, and the rubber had just vanished from the face of the earth. But the crisis did not stop at the battlefield. It reached into every driveway, every garage, every farm road in America. The country had 27 million registered automobiles. Those automobiles sat on 112 million tires, and those tires were wearing out. There were no replacements. You could not buy a new tire in the United States. The government banned civilian tire sales 11 days after Pearl Harbor. It was the first item rationed, before sugar, before coffee, before gasoline. Tires came first, because without tires, America stopped. Bernard Baruch, the 72-year-old Wall Street financier whom Roosevelt had appointed to study the crisis, delivered his committee's report on September 10, 1942. The language was not diplomatic. It was a warning siren. We find the existing situation to be so dangerous that unless corrective measures are taken immediately, this country will face both a military and civilian collapse. He was not talking about a budget problem. He was talking about the end of mobility, the death of the American way of war. The Baruch Committee recommended something that would have been unthinkable a year earlier. A nationwide speed limit of 35 miles per hour. Not to save gasoline, because there was no gasoline shortage. To save rubber. Every mile driven at 60 burned rubber off the tires twice as fast as a mile driven at 35. The victory speed limit went into effect across the country. Gasoline was rationed not because it was scarce, but because rationing gasoline was the only way to keep Americans from driving their tires into the pavement. Think about that for a moment. The most mobile nation in the world, the country that had built its entire identity around the freedom of the open road, was told to slow down and stay home because a tree on the other side of the planet was now behind enemy lines. Now, the obvious question. Why did the United States not simply grow its own rubber? The answer tells you something painful about pre-war complacency. They had tried. Henry Ford, in 1928, had purchased 2.5 million acres of Brazilian jungle along the Tapajós River and built an entire town called Fordlandia, complete with American-style houses, a hospital, swimming pools, and a golf course to grow rubber for his automobile factories. Ford imposed Midwestern values on the Amazon. He banned alcohol. He required workers to eat American food. He planted rubber trees in neat, orderly rows, the way you would plant corn in Michigan. It was a catastrophe. The rubber trees, crowded together on a plantation instead of dispersed through natural jungle, were devastated by South American leaf blight, a fungal disease that thrived when trees grew close together. The soil was wrong, the insects were relentless, the workers revolted against the cultural impositions. Ford lost millions and eventually abandoned the project. The jungle reclaimed Fordlandia, swallowing the houses and the swimming pools, and the dream of American rubber self-sufficiency. There were experiments with guayule, a gray, unassuming desert shrub native to Mexico and the Chihuahuan Desert of Texas that produced a form of latex in its stems and roots. The Emergency Rubber Project, launched after Pearl Harbor, planted 32,000 acres of guayule in California. But guayule grew slowly. It took 3 to 4 years to mature enough for harvest, years that did not exist. There were contracts with Firestone's plantations in Liberia, which provided some natural rubber, but Liberian output covered barely 2% of American wartime consumption. Latin American wild rubber was tapped under emergency agreements with 26 nations, but the quantities were pitiful compared to the need. The jungle was too vast, the trees too scattered, the labor too scarce. Wild rubber tappers in the Amazon collected a few pounds a day. America needed hundreds of thousands of tons per year. There was only one path out. If America could not grow rubber, it would have to make rubber. From petroleum. The idea was not new. The chemistry of synthetic rubber had been understood since the early 20th century. In 1909, a Bayer laboratory in Germany had synthesized isoprene, a building block of natural rubber. During the First World War, Germany, cut off from tropical rubber by the British naval blockade, had produced a crude synthetic rubber called methyl rubber. It was terrible. It cracked in the cold, it melted in the heat, but it kept German trucks rolling just long enough to matter. After that war, the Germans never stopped working. IG Farben, the massive German chemical conglomerate, developed a family of synthetic rubbers called Buna in the early 1930s. Buna S, a copolymer of butadiene and styrene, was the most promising. It could be made from coal. Hitler, preparing for a war of aggression and determined to make Germany self-sufficient, poured state subsidies into Buna production. By 1939, Germany had operational synthetic rubber plants. They were expensive, the product was inferior to natural rubber, but it existed. And here is where the story turns dark before it turns heroic. Standard Oil of New Jersey, the largest oil company in the world, had maintained a deep commercial relationship with IG Farben since 1930. The two companies had formed a joint venture called the Joint American Study Company, later renamed JASCO, to share chemical patents and refining processes. Among the technologies exchanged were IG Farben's patents for Buna rubber. Standard Oil acquired the American rights. In return, IG Farben received access to Standard Oil's refining technology, including the tetraethyl lead process that improved gasoline performance. It was a marriage of industrial convenience between the two most powerful chemical entities on the planet. But Standard Oil did more than just license Buna. Its own researchers, working with the German patents, developed a new form of synthetic rubber called butyl rubber in 1937. Butyl rubber held air 13 times better than natural rubber. It resisted aging, weathering, chemicals, and moisture. It was ideal for inner tubes and seals. It was an American innovation built on a German foundation. Yet, in the years before the war, Standard Oil did not build large-scale synthetic rubber plants. It sat on the patents. The reasons were complicated, tangled in corporate strategy, antitrust considerations, and the simple fact that natural rubber from Southeast Asia was cheap and plentiful at 4 cents a pound. Why invest hundreds of millions in factories to make an inferior product when plantation rubber cost pennies? When the war broke out, this inaction exploded into a political scandal. Senator Harry Truman's committee investigating the war effort hauled Standard Oil executives before Congress. The accusation was blunt. Standard Oil had entered into agreements with a German company that suppressed the development of American synthetic rubber. The company's president defended the relationship, arguing that the patent exchange had actually given the United States access to German technology it would otherwise never have had. The truth, as usual, sat somewhere in the ugly middle, but the result was clear. America entered the war with knowledge of how to make synthetic rubber and almost no capacity to actually produce it. In 1940, only 0.4% of American rubber was synthetic. Total domestic production in 1941 was approximately 8,000 tons. The country needed over 600,000 tons per year. The gap was not a gap, it was an abyss. Roosevelt moved. In June 1940, even before Pearl Harbor, he had created the Rubber Reserve Company, a government agency within the Reconstruction Finance Corporation tasked with stockpiling natural rubber and accelerating synthetic rubber development. The stockpile peaked at around 634,000 long tons in April 1942, a cushion that bought the country roughly 1 year of breathing room. But stockpiles are a clock, not a solution. Every day that passed, the pile shrank. The plan that emerged was the most ambitious chemical engineering project in American history, second only to the Manhattan Project in cost and complexity. The government would finance the construction of an entirely new industry from the ground up. The Reconstruction Finance Corporation would pay for the factories. Private companies would operate them under contract. The product would be a standardized synthetic rubber designated GRS, Government Rubber Styrene. It was Buna S made in America, using the German chemistry that Standard Oil had acquired, improved by American engineers, and scaled to a size that would have astonished even IG Farben. The chemistry was this. Butadiene, a colorless gas derived from petroleum, was polymerized with styrene, a liquid hydrocarbon, in the presence of a soap-based emulsion at controlled temperatures. The resulting material was a synthetic latex that could be coagulated, washed, and processed into sheets of pale, rubbery material. It smelled nothing like natural rubber. Where natural latex had a sweet, organic, almost milky odor, GRS smelled of chemicals, of petroleum distillates and soap residue. It felt different in the hand. It was stiffer. It generated more heat under friction. A tire made of pure GRS wore out faster than a natural rubber tire and ran hotter at highway speeds. It was, by every qualitative measure, an inferior product. But it was a product that could be made from oil, and America had oil. The factory construction program was staggering. 51 plants were authorized. They rose across the Gulf Coast, the Midwest, and the Eastern Seaboard in places like Port Neches, Texas, and Baton Rouge, Louisiana, and Institute, West Virginia, and Akron, Ohio. The butadiene plants, which produced the primary feedstock, were built adjacent to petroleum refineries. The polymerization plants, which combined butadiene and styrene into rubber, were built near the chemical infrastructure needed to supply them. The entire program cost nearly $700 million. Adjusted for inflation, that is the equivalent of roughly $12 billion today. It was a third of the total cost of the Manhattan Project. The speed was inhuman. Construction crews worked around the clock. Steel, concrete, and piping were consumed at rates that competed with shipyard and aircraft factory demands. Standard Oil of New Jersey, despite the political controversy surrounding its IG Farben connections, was at the center of the effort. The company operated multiple plants and supplied critical butadiene production technology. Its engineers had spent the 1930s quietly studying the Buna process, and that knowledge, so politically toxic in the Senate hearings, now became the foundation upon which the program was built. The irony was not lost on anyone. The same patents that had been denounced as evidence of a cartel were now saving the war. Other companies were essential. Firestone, Goodyear, Goodrich, and U.S. Rubber, the big four tire makers, operated the polymerization plants. Dow Chemical supplied styrene. Phillips Petroleum and Humble Oil contributed butadiene. It was a forced collaboration between corporate rivals, mandated by the government, funded by the taxpayer, and driven by a deadline that did not care about quarterly earnings. Companies that had spent decades suing each other over patents were now sharing laboratory notebooks. Engineers from competing firms sat in the same conference rooms, working on the same production problems, eating the same cafeteria food. The government had suspended antitrust law for the duration of the war, and the suspension created something that peacetime capitalism could never produce: an industry built by enemies working as allies. The logistics of building 51 chemical plants simultaneously were almost as complex as the chemistry inside them. Steel was rationed, copper was scarce, skilled welders were being drafted. Construction crews had to compete with shipyards and aircraft factories for every rivet, every I-beam, every foot of pipe. In Port Neches, Texas, a butadiene plant rose on marshland that had to be drained and stabilized before a single foundation could be poured. In Institute, West Virginia, a plant was built on a narrow shelf of land between the Kanawha River and a hillside, the piping running at angles that would have given a peacetime safety inspector nightmares. In Baton Rouge, Louisiana, construction crews worked through summer heat that touched 110 degrees, pouring concrete that had to be cooled with ice water to prevent it from curing too fast and cracking. The plants themselves were brutal environments. Butadiene is a volatile, flammable gas. Styrene is toxic. The polymerization process required precise temperature control. The emulsion reactors, massive steel vessels lined with specialized coatings, operated under conditions that demanded constant human attention. Workers in the butadiene plants labored in the shadow of distillation columns that rose 100 feet into the Gulf Coast sky, surrounded by a web of piping that hissed and groaned with pressurized hydrocarbons. The heat in a Texas chemical plant in summer was punishing. The smell was inescapable, a thick blend of petroleum vapor and chemical reagents that clung to clothing and skin. Explosions were not hypothetical, they happened. Fires broke out, men were burned, but the plants kept running because the alternative was losing the war. Production began to trickle in late 1942 and then surged. In 1942, American factories produced 22,434 tons of all synthetic rubber. In 1943, the number jumped to 234,000 tons. In 1944, it crossed 753,000 tons. By 1945, the 51 government-financed plants were producing over 820,000 tons per year, far exceeding the entire pre-war American consumption of natural rubber. The United States had gone from an annual pre-war production of just 231 tons of synthetic rubber to a monthly output of 70,000 tons. It had built, from nothing, the largest synthetic rubber industry on the planet. It had done it in less than 3 years. It was an industrial acceleration that had no precedent and has had no equal since. The rubber went everywhere. It went onto the tires of the 2.5-ton GMC trucks that hauled ammunition across France after D-Day. The Red Ball Express, that legendary convoy route that fed Patton's Third Army during the sprint across France in the summer of 1944, consumed tires at a rate that would have been impossible without synthetic rubber. Trucks ran 20 hours a day on roads that had been cratered by artillery and littered with shrapnel. Tires blew out constantly. They were replaced from stockpiles that had been manufactured in Texas and Louisiana and shipped across the Atlantic in the holds of Liberty ships. It went into the treads of the M4 Sherman tanks that ground through the hedgerows of Normandy. It sealed the turrets of B-17 bombers flying at 30,000 feet, where temperatures dropped to -60 degrees, and the rubber gaskets had to remain flexible enough to keep pressurized air inside the fuselage. It insulated the wiring of radar sets on destroyer escorts hunting U-boats in the North Atlantic. It lined the fuel hoses of P-51 Mustangs escorting bomber formations deep into Germany. It formed the gaskets on submarine hatches that kept the Pacific Fleet alive beneath the waves. It cushioned the recoil mechanisms of artillery pieces that fired thousands of rounds during the bombardment of Iwo Jima. every piece of rubber in every theater of the war was either natural latex from a dwindling stockpile or synthetic GRS from a factory that had not existed 2 years earlier. It made the war move. But GRS was never as good as natural rubber. The tire companies knew it, the military knew it. Truck tires made of synthetic rubber wore down faster, especially in the African and Pacific theaters where heat and rough terrain punished the material. The solution was blending. Whenever natural rubber was available, even in small quantities, it was mixed with GRS to create a composite that performed better than either material alone. The small trickle of natural rubber from Liberia, from Latin America, and from reclaimed scrap was not wasted. It was treated as a strategic additive, a biological corrective to the shortcomings of petroleum chemistry. On the home front, the consequences of the rubber crisis reshaped daily life in ways that no other shortage matched. Gasoline rationing touched every family with a car. The 35-mile-per-hour Victory speed limit transformed the American highway from a symbol of freedom into a disciplined exercise. Signs across the nation were replaced overnight. In Utah, highway patrol studies found that 46% of cars driven by war workers had at least one tire worn completely smooth. 23% had two smooth tires. These were not old jalopies. These were the only cars Americans had, and they were falling apart on the road. You could not buy a replacement. You could not even buy a retread without a government certificate proving you needed one for essential war work. Scrap rubber drives became civic rituals. Roosevelt called on every American to turn in old tires, garden hoses, rubber boots, hot water bottles, anything made of rubber. In a single drive in June 1942, Americans donated over 450,000 tons of scrap rubber. Children pulled rubber balls from toy chests. Women surrendered girdles. Farmers brought in tractor tires they had been hoarding. Gas station owners piled rubber doormats and floor mats at collection points. The material was processed at reclamation plants, where it was shredded, devulcanized with heat and chemicals, and blended back into usable stock. Reclaimed rubber was inferior even to GRS, but it was rubber, and in 1942, rubber was more precious than ammunition. Meanwhile, Germany faced its own rubber crisis from the opposite direction. The Reich had been producing synthetic Buna rubber since the mid-1930s, but demand always outstripped supply. IG Farben built a massive Buna plant at Auschwitz III, using slave labor from the adjacent concentration camp at Monowitz. Tens of thousands of prisoners were worked to death constructing and operating the facility. The plant never reached full production. Allied bombing and the deliberate cruelty of the SS management ensured that the most ambitious synthetic rubber factory in Nazi Germany was also one of the most horrific crime scenes of the Holocaust. The contrast is essential. Both nations needed synthetic rubber. One built its factories with free labor and government contracts. The other built them with enslaved human beings. The chemistry was identical. The morality was not. What makes this story different from the other industrial miracles of the war is the political chaos that surrounded it. The synthetic rubber program was not a clean, heroic narrative of engineers and patriots pulling together. It was a brutal, messy fight between oil companies and farm lobbies, between army procurement officers and civilian bureaucrats, between free market ideologues and government planners. The question of feedstock alone nearly derailed the program. Butadiene, the essential ingredient, could be produced from petroleum or from grain alcohol. The oil industry pushed petroleum. The farm lobby, backed by powerful congressional allies from the Midwest, pushed grain. The petroleum route was cheaper by a factor of 3 to 4, but the farm lobby was politically formidable. For months, the argument raged while factories sat half-built and the rubber stockpiles shrank. Roosevelt's appointment of the Baruch Committee was a political masterstroke designed to cut through the paralysis. Baruch's report was brutally clear. Use petroleum, build the plants, ration gasoline, stop arguing. The appointment of William Jeffers, president of the Union Pacific Railroad, as rubber czar with sweeping authority finally broke the logjam. Jeffers was a blunt, profane man who had no patience for lobbyists. He forced the program through. The legacy of the synthetic rubber program outlasted the war by decades. When victory came in 1945, the United States possessed an industrial capability that had not existed 4 years earlier. The 51 plants were government property, operated by private contractors. They represented a permanent capacity to produce rubber from petroleum, freeing the country from its dependence on tropical plantations forever. By 1950, synthetic rubber consumption in the United States exceeded natural rubber for the first time. Today, more than 70% of all rubber produced globally is synthetic. Every tire on every car on every highway in the world descends from the chemistry that was scaled in those frantic Gulf Coast plants between 1942 and 1944. The program cost $700 million and likely saved the war. Historians at Yale have argued that the synthetic rubber program was more important to Allied victory than the Manhattan Project. The atomic bomb shortened the war, but without rubber, there would have been no war to shorten. Without tires, the trucks stop. Without gaskets, the ships flood. Without insulation, the radios go silent. Without rubber, the greatest military machine ever assembled becomes a collection of immobile metal sculpture rusting in a field. Standard Oil of New Jersey, the company that had been dragged before Congress and accused of collaboration with the enemy, ended the war as one of the architects of American survival. The same patents that had been called treasonous became the blueprints for 51 factories that produced the material that kept the wheels of the Allied war machine turning. The engineers who had studied the Buna process in peacetime laboratories found themselves running production lines that fed the invasion of Europe. The corporate sin of pre-war complacency was redeemed, partially, imperfectly, by the industrial heroism of wartime production. But there is a colder truth underneath this story, one that the victory parades did not acknowledge. The rubber crisis should never have happened. The United States knew, for years before Pearl Harbor, that its rubber supply was dangerously concentrated in a region vulnerable to Japanese expansion. Military planners warned about it, industrialists warned about it. The Rubber Reserve Company was created in 1940 precisely because the threat was recognized. As early as 1938, rubber company executives were testifying before Congress about the danger. Standard Oil's own CEO, Frank Howard, wrote to government officials in May 1941, pleading for a clear directive. If we are to meet an emergency, he wrote, the 4 large companies must know in advance how to provide synthetic rubber. But knowing and acting are 2 different things. The stockpile was too small. When Singapore fell, the United States had roughly 634,000 tons of natural rubber in reserve, barely enough for 1 year of wartime consumption. The synthetic rubber plants were authorized too late. The political infighting between the oil industry and the farm lobby over whether to use petroleum or grain alcohol as the feedstock for butadiene delayed construction by critical months. Congress passed bills that Roosevelt had to veto. Agencies competed for authority. Bureaucrats argued while the clock ran. The Baruch Committee, in its September 1942 report, did not mince words about the delay. Wrong things done in the past cannot be cited as a defense for making mistakes in the future, Baruch wrote. The war demands that we do these things. Victory can be won in no other way. If Singapore had held for 6 more months, or if the factory program had started 6 months earlier, the crisis might have been a problem instead of a catastrophe. The margin was that thin. The American synthetic rubber program succeeded not because it was well managed from the start, but because the sheer industrial capacity of the United States, once fully mobilized, could overcome even the most spectacular failures of planning. That is the lesson buried inside this story. Not that America built 51 factories and saved the war. America did that, but America almost did not do it in time. The margin between victory and disaster was measured not in battalions or bombers, but in tons of butadiene and months of construction. The tree bled white in the jungle, and the empire that depended on its sap discovered, almost too late, that empires cannot be built on a single supply line, no matter how cheap the product or how distant the threat seems. The factories are mostly gone now. Some were dismantled, some were converted. A few still operate in modified form, their wartime origins buried under layers of corporate restructuring and modern chemical processing. But the rubber they made is still rolling. Every synthetic tire on every road in the world carries a molecular echo of those desperate years when America learned, the hard way, that the most dangerous weapon in a global war is not a bomb or a bullet. It is a shortage of something so ordinary, so invisible, so taken for granted that nobody thinks about it until it disappears. Rubber disappeared in February 1942, and 51 factories rose from the Texas mud, the Louisiana swamp, the West Virginia hollows, and the Ohio flatlands to bring it back. They rose because the most ordinary substance in the world turned out to be the most critical, and because the men who built those factories understood what the men who had failed to plan for the crisis did not. In war, the weapon you run out of first is never the one you expected. It is never the bomb. It is never the bullet. It is the thing you never thought about, the thing that holds everything else together, the thing that bends and stretches and absorbs the shock so that the machine keeps moving. That is rubber. And in the spring of 1942, that is what America did not have, until it did.